So, okay, in this talk, I will review a little bit the practical, as Joaquin said, the practical methods and so on. And already I want to say, and you will see some slides that that I use in the previous course and so on. So it's more a rephrasing than really something new for you. So in the last April, in the first course of the observatory, we conclude that we are going to apply the random encounter model as a reference method. I told you in that course that there is a recent paper reviewing all the random encounter model application in different species around the world and different situations. Nowadays, this paper is already published and is available online in open access. You can have a look. And yeah, coming back to the REM formula, and also Patrick already explained a little bit the method, so I will be even faster than expected. This is the random encounter model formula with which we estimate the density considering three main parameters. The first one is the encounter rate, which indicates the number of animals detected per sampling unit, in this case per camera day. So considering all the animals, and as I will repeat later on, we are working usually with the individuals at the unit of observation. So we are not working with groups, we are working with individuals animals at the unit of sampling or the unit of observation. So the encounter rate represents the number of animals in all the cameras in all the study period. Then we have a second parameter, which is the day range, the distance traveled by each individual in the population every day. So the average of all the animals in all the population, and let's say 5 kilometers per day or 10 kilometers per day or whatever. And then we also have two parameters actually. One parameter which is the detection zone, which is divided in two parameters, the radius and the angle. And this is the area in which the camera effectively detects the animals when cross or when enters the field of view. And finally, with these three main parameters, we will estimate the population density, which is the number of individuals per square kilometer or per hectare or whatever. So how we estimate each of these individual parameters. So here, before I will start with some videos and then we will focus on real example from camera tracked pictures. But for the encounter rate, as said before, each time that one individuals, as you can see in this video, each time that the individuals enters in the field of view in the detection zone, we will consider like two encounters. So independently, that is just that a given animal enter, let's say 5 seconds or 2 seconds after this same animal or not, because you know that when we are working with random encounter model, we are usually working with a species in which it's impossible or almost impossible to differentiate one wild boar, for instance, from the potential other second wild boar. So when we have a wild boar that enters in the field of view, then the animals go out. And 5 seconds later, for instance, or 1 minute or 1 hour, the same. Another wild boar, maybe the same one, but we never know. Another wild boar enter the field of view, we should consider this animal, this individual, as a second new encounter, okay? So as you have here, we have to count every time that an animal enters the detection zone or the field of view of the cameras. Then, for estimate the detection zone, the radius and the angle, when the camera is activated, so it means in the first picture or in the first sequence, if we are working with videos, when the animal enters the field of view and the camera was activated, we record the distance between the camera and the animal. Only in the first, let's say, when the animals enter, okay? When the animals activate the camera, not in all the sequence. Also, Patrick have explained this concept before. And for the angle, let's suppose a simple example for in which the angle of the the angle of view of the camera is 40 degrees, we usually set 0 in the center of the field of view, and then in this case, obviously, you have 20 degrees to one side and 20 degrees to the other side. So we, again, in the first picture of each sequence, so when the animals activate the camera, we also estimate the angle, considering that the 0 degrees is the center of the field of view. So imagine that in this case, we are considering like the reference point, this front leg of this whale bar, for instance. So in this case, the angle of detection for this individual in this specific sequence will be 20 degrees. So one more example, just to clarify this concept. The first photo, when the camera was activated, in this case with a red fox, we record the distance between the animal and the camera, and we also record the angle of detection. Obviously, in this case, it's not 20 degrees because it's more in the 1/4 of the field of view, but in this case, we will record this angle, which is drawn in white. And finally, for the last parameter, we have already seen encounter rate, we have already seen detection zone. Now focusing on the speed, and at this point, I would like to clarify, because there are already some questions in the previous lecture, that what we conclude in the first observatory course was that we are going to, by the moment, work with two types of reference, let's say, to estimate the location of the animals in the field of view, or to estimate the coordinates of the animals in the field of view. The classical one is this one, in which I'm going to show more picture later on, but in which we set reference in the field of view in a given distance, for instance, 2.5 meters, 5 meters, 7.5 meters, and 10 meters. So then the estimation of the distance is done manually. Or alternative, you can, or what we also recommend is to calibrate the picture with this white and black pole that we have already seen all the morning today. But there are two totally, let's say, independent approaches to finally get the same result, which is estimate the location of the animals in the field of view. So all that is related with the calibration with the poles and so on, you should implement and click in the picture as Patrick already so on to estimate the location. But if you want to work for any reason, if you want to use this reference, this natural reference in the field of view in a given distance, then you can work outside of Aguti, let's say. Or I mean, you can import the photos to Aguti, but it's not necessary to cross the information with the calibration pole and so on. Okay. So in any case, as mentioned before, we said reference, natural reference, stone, rocks, branches, and so on, as you can see here, in a given and in a known distance in the field of view. And then we are we recreate or reconstruct the trajectory, in this case of this whale board, when crossing the field of view. Okay, so here you have this stone of 5 meters, and here we have the stone for 2.5 meters, and we recreate. This black point represents its location of the whale board in the photo. We estimate the speed. In this case, let's say that it is 2.5 meters from this point to the last one, which is this photo. You can see the animal in this photo is leaving the field of view, and then you can see my my screen, yes. So as the camera stamp the time and the date also, but in this case the more important is the time. We know that the animal travels these 2.5 meters in 2 seconds, so we have an individual speed for each, or a specific speed for each animal crossing the field of view, let's say, of all the cameras in our study. And again, as Patrick already mentioned, to estimate the range, we need two parameters. The first one, or one of them, is the speed when active. I mean, when the animal is walking or staying on or whatever. The speed, when the animals are in movement. But we also need to estimate the proportion of the day when the animals are in movement or are active, and this is what the activity level parameter. So just as you already know, also every single picture that we record with a camera trap, we always have the date and time in which each photo was recorded. So then we can create this, let's say, frequency plot, more or less, in which we indicate at which time each individual in all the photos and in all the cameras have been recorded. So here we have in this plot, in this activity pattern plot, we have the information of all the photos, all the cameras, and all the animals for a given species, obviously. So in this case, we show a maximum of activity pattern at the sunset, more or less around 8 o'clock in the afternoon. Yeah, this is the activity pattern, which indicates that the population have a maximum of activity. Here we assume that all the individuals are active at this point. And what we already need for estimated day range is not only the activity pattern, is the activity level, which in some way is the area under this red curve. But activity level always take values between 0 and 1, and 0 represents 0 hours per day of activity, 1 24 hours of activity per day. So, for instance, a given value of 0.5 activity level represents that the population, all the animals in all the wild birds, for instance, in our population spend active 12 hours per day. Okay, so then when we multiply this average speed when active with this given value, let's say of 12 hours active per day, we cross this data and we estimate the day range. And here I come back to the formula again. We see the three parameters that I already mentioned before, and I create these very simple and stupid data frames in which you can see what the information that we need to estimate each of these REM parameters. Okay, so obviously Aguti, or when you process if you use the calibration pole approach, or if you use the manual estimation of distance, you will have different data frames. I mean, the columns when exporting the Aguti results and so on will be different for sure, but at the end, the basic information, or we need to summarize in some way the information to these specific data frames. Okay, so starting by the encounter rate, what we need is here one column with all the cameras, all the cameras or all the deployments. Then we need a second column, which is this number, the numerator, which is the number of encounters. Remember, we are working with the individual as the unit of observation. So let's say that we have 20 wild birds animals crossing the field of view in these cameras during a survey period, in this case, for instance, which is the denominator T here, of 21 days, for instance. Okay, so the camera one was working 21 days, and 20 wild birds were recorded in this camera. Then also you can it's important to record information about when the camera was working properly. For instance, if you use this calibration, this automatic calibration procedure to estimate the distance, and as we already discussed, you discard part of the data because the camera was moved or whatever, and you don't have new pole calibration photos. So then you should also discard that the camera in these days was not working properly. Okay. And obviously, you will have also some cameras, for instance, in this case, the camera 4, in which the camera was working all the period, in this case, 3 weeks, but no wild bird crossed the field of view. But in any case, you should also include in the final estimation of the density, as we will see in the next course in 1 month, more or less, you will also consider those cameras that were working in the field, but in which we didn't record any individual of our target species. Okay, so this is for the encounter rate. Then for the detection zone, we will have for each individual, please note that here now the first column is not the camera, is the individual ID or the animal, or the wild boar if you prefer. For each animal, when the animal enters the field of view and activates the camera, we will have a detection radius and a detection angle, okay? And then we will have for each animal when enters a given camera and activates the camera, okay? So we have the radius, here we have the radius, and we have the angle in degrees or in radians, is the same. Later on we will transform to radians, which is here. Here we have the parameters. And finally, for the day range, as I mentioned before, we need two parameters: the speed of movement or the travel speed. The speed when the animals are in movement, and we also need the activity. Okay. So the speed, as mentioned before, when the animals cross the field of view, we estimate the speed of each individual animal. Later we will see some exception, but by now let's say that we estimate the speed of each individual. And we will also record the time in which each individual enters the field of view of a camera trap. Okay, and here we have this information in another column. And here, exceptionally, I include the group site parameter, which represents, for instance, in this group, we record two wild boars. In this case, it's important. Imagine that we record a female and a piglet. Okay, and this is different of the concept of number of encounters for the encounter rate. Okay, so for the encounter rate, I repeat, each time that the animals enters, go left, and then enters again the field of view, we shall record a new encounter. But for the activity, this is for the estimation of the activity, as you can see here. If we have a female with one piglet, for instance, and let's say that this female enters 2 times on the field of view. In this case, the group size is not 3. The group size is still 2, because here we are going to estimate the number, or we need to know the number of animals which are active in every time of the day. Okay, so it's important to know that there are 2 animals at 11:30 in the night, for instance, let's say. And however, only around 8 o'clock in the morning, there were we record only one individual. Okay. So this is the information that or the data that we should record for each, for estimation of each REM parameters. And finally, again, but this is not specific for REM. If you work with camera trap, do you almost ever need this operativity matrix, or just to know when the cameras were working properly? So in the first column, or in some point, you need to have the camera trap placement or the camera trap deployment. So camera 1, 2, 3, 4, and so on. Then you should indicate with 1, or how I work is indicating with ones when the camera was operative all the day. So it's important to say all the day, the 24 hours per day. And then, for instance, in this example, here we have a 0 because the camera was not operative because many reasons, empty batteries, full car, the camera was stolen, whatever. Okay, so then we need to have in mind also and put in the model, if you remember, in this parameter, in the denominator here of the counter rates, the total number of days that we were working in, or that we were sampling our population. So now after this general introduction, I will deep in detail with some real example. Okay, I'm going to explain here the protocol of the natural reference, but obviously or potentially we will have also done the calibration with this black and white pole. But in any case, here you can see the reference at 2.5 meters in white, in yellow, the reference at 5 meters from the camera, In green, this natural reference at 7.5 meters. And finally, in red, we have the reference at 10 meters. Okay, so considering this example, because I'm going to show a picture here of the same camera trap placement. So in the first photo, if you remember, obviously we are going to estimate encounter rate, in this case, one wild boar, because we will see only one individual here, the detection angle. So in the first photo, we will estimate the angle, remember, considering that 0 degrees is the center of the field of view. Then also the detection radius, the time, which is here for estimate the activity pattern and the activity level, and the speed, which we will use all the photos. Okay, so as I want to represent here is that we only record especially the detection angle and the detection radius in the first photo of the sequence, and then the other photos in the sequence, in this one only 3, will be useful to estimate the animal speed. So finally, coming back to my simple data frame example, in this case for the encounter rate, we will have one wild boar. I don't know which camera, whatever. Okay, it's not relevant here, and the number of days. Obviously we need to know the survey period of this individual camera, but in general, I think that this is quite obvious. So here we have one encounter. Then for the radius and for the angle, remember, for the first photo, we will estimate the radius 4.3 meters in this case, and the angle of view. So this is for the detection zone only from this photo. And then from the day range, we will have the time here, as you can see here from the first photo. Here is the time. We will estimate the travel speed using these 1, 2, and 3 photos. And then the group size here is 1 because we have only one individual, one wild boar here. Okay, so this is, let's say, a simple example. Here we have a little bit more complicated example. Again, we have, as mentioned before, one wild boar female that enters the field of view. This is the first photo, and here we record the encounter rate. So by now, one encounter, the detection angle and detection radius, the time for the activity estimation, and the speed using this photo, this, and the last one. Okay, and obviously this is the same using the manual or the traditional, let's say, approach to estimate the speed or to estimate the REM parameters than if you use the automatic or the calibration approach to estimate the REM parameters. Okay, we will only use, I repeat, the first photo, when the camera was activated, to estimate the radius and the angle, but we will use all the photos to estimate the speed. Okay, or the day range finally, let's say. But in this case, you can see here, this wild boar leaves the field of view here by this female. And then just a few seconds later, in this case, 8 seconds later, we have another younger individual that crossed the field of view running. So in this case, actually, we only have this photo. So we only have one photo of the second individual. So for this individual, as this is a new activation of the camera, we can estimate again, or we can record again, the detection angle and the detection radius. And we also need to take into account this individual for the encounter rate. So here we have 2 encounters, one from the female and the second one for the young individual. So here again, as mentioned before, you have 2 encounters, one of the female, one of this second individual. We have 2 detection radius, one for the female in the first photo, here second one for the younger, because this is another independent activation. If you, I don't know if you can see here the time of the photos, but the time lapse between this first photo and the last one is just 3 seconds. So we have 4 photos in 3 seconds. So obviously this is the same activation, and here we have a time lapse of 6 and plus 2, 8 seconds between the last photo of the female and the first one of the new young individual. So we have 2 activation of the cameras, and then we can record two detection radius and detection angle in this group of wellbore, let's say, because again, as mentioned by Patrick, and usually as higher the sample size, as more accurate and precise the estimation. Okay, so we have here the two detection radius and angle for the two individuals, and for the speed, as mentioned before, we only have one speed value here because for the second individual we only have one photo, so it is impossible to estimate a speed with one photo. Okay, and we have the time for the first one. In this case, is not relevant to. I mean, it's just 11 seconds later, so the time for the first individual should work to estimate the activity. And the group side is 2, because here we have two, I mean, a clear example with two different individuals of wild boar. Okay. Next example. Again, this is a little bit simple, but in this case, we only have one photo again because the animal, this individual was running, so we only have one photo. So we will estimate the encounter rate, we will estimate the detection angle, we will estimate the detection radius, and we will estimate the time for estimate later on the activity pattern. But we don't have a speed because, as mentioned before, with one photo or one picture is impossible to estimate the speed. Okay, so this camera was a little bit slow and only record one photo of this animal, which actually, as you can see, was running. So we have one encounter, we have the information or the data for the radius and the angle. We have the data for the data for the time, but we don't have a speed, okay, because it's impossible, and the group size obviously is 1. Next example, and this is, I mean, I think that this has not been mentioned before today, and I would like to clarify this aspect, which is that in those sequence or in those encounters in which the animals enters the field of view, in which the animals enter the field of view and the animals react to the camera traps. For instance, as you can see here, the wild boar is exploring in some way the camera. It is not necessary to estimate the speed. I mean, Patrick or Marcus can correct me, but what I said is that it is not necessary to estimate the speed of this animal reacting to the camera, because then when we analyze the data, we will discard this anomal behavior, let's say, of the animals reacting to the camera trap. Okay, so here, obviously, potentially, we can estimate the speed because we have 5 photos of the same individual, but that the individual is reacting to the camera. As you can see, it is not necessary to estimate the speed because we can finally introduce bias in somehow in the day range. Okay. So, and obviously the other parameters for sure, we should record the encounter rate because we have one wild boar enter the detection zone. We can estimate the detection angle and radius when the camera was activated, and obviously we can record information of the time to estimate the activity pattern, because here you can see that we actually have one wild boar in a given camera that were active around 9 o'clock in the night. Okay, so here again, the data frames as usually, and I mark here in red that it is not necessary to estimate the speed in this example. And we shouldn't estimate the speed even we are doing it manually with the traditional protocol or we are doing it in Aguti. So if you work with Aguti and you have a sequence similar to this one, just click in my advice. Again, if Patrick or Marcus want to say something, but my advice, is to click only here in the first photo and then continue with the next encounter. So here, other more, let's say, complicated or difficult example. We have in this case 7 photos of a wild boar. Obviously, as usual, we will estimate the encounter rate, detection angle, radius, time, and speed using these 3 photos of this wild boar. But again, I don't know if you can see the time properly or not, but I'm saying that this last photo from this photo to the next one, which is this one, is around 1 minute and 20 seconds, more or less. So obviously here we have this wild boar. At some point, the animals go out of the field of view and later enters again. So in my opinion here, looking the size of the animals and other characteristics, I should say that this is the same wild boar, but again, it's not relevant for the random encounter model because we should consider here two encounters. Even if we think or even if we assume that this is the same individual, this is the same wild boar, we should consider this like two encounters. Okay. So here again, I mark in red these two encounters. So these three photos are one encounter, and these 1, 2, 3, and 4 last photos are the second encounter. Obviously, in the second encounter, we have another independent activation of the camera. So again, we can, sorry, here it is a mistake. So I mean the information here is correct. We can estimate two detection, I mean a new detection angle and a new detection radius here, but I should complete this data frame. So and I will update and later send to Joaquin again. But in any case, here we have two encounters, two activation of the camera. So we can record two detection angle, one in this photo and the another one in this one. Okay. And here we have again the time for the activity. Only one time because, as mentioned before, it's just 1 minute and a half more or less of difference. So with the first time is enough. The speed of these animals, but I mark in red here that we are not going to estimate true speed, because as you can see, especially in this photo and then in this one, the animal is reacting to the camera, as you can see here, and then the animal runs. So in this case, again, we shouldn't estimate speed because the animal is reacting to the camera. And finally, I mark in red the group size is one, sorry, because as I mentioned before, I'm assuming here that this wild boar is exactly the same than this one. Okay, so this is the group size of one, but the more important for REM is the number of encounter, which in this case is 2. Okay, I will update this slide later. And I'm close to finish by now, but yeah, I copy again this slide from the previous course. And if you remember, one of the take-home messages was that that we need to somehow to estimate the coordinates or to locate the animals, the individuals in the field of view of the camera trap. And what I say, especially in more detail in the first course, is that for most of the recent methodologies that have been described to estimate population density of unmarked species using camera traps, and here we have the random encounter model, but also the random encounter and staging time and the camera trap distance sampling, you need in somehow to estimate the location of the animals in the field of view. For the RES to know if the animals are inside or not of this triangle of perfect detection, and then estimate encounter rate, and for the camera trap distance sampling to estimate the probability here, this parameter, the probability of detect an animals in the field of view. So for all these three methods, we need to estimate the location of the animals in the field of view. In some of them, for instance, it is not necessary to estimate the speed, but at the end, we need to know in somehow the coordinates of the animals in the field of view. And actually, one question from my side is if the Aguti output, when using the calibration poll, returns the coordinate, return the data in some way that we can apply more than one method, not only the REM, but in any case, we will clarify this aspect later. But we need the location of the animal or the coordinates of the animals in the field of view, and finally, here in the supplementary materials of this paper and also in the supplementary materials of the previous course, we show it, I mean, we provide a video with the estimation of the parameters for all the three methods. And here you will see, okay, just to clarify again that we need to estimate the location, the coordinates of the animals in the field of view. So the REM is what I mentioned before. We need the radius and the angle in the when the animals enter the field of view, when the animals activate the camera, and then we estimate the speed. For the RES, we need to know when in this case the fox is inside of the triangle of detection. And for the camera trap distance sampling, we work with snapshot moments, and in each snapshot, we estimate the distance again between the animals and the camera. I'm on time, so now it's time for questions. So, okay, so I can see the chat. Okay, Marcus and Patrick also clarified that it is not necessary to use speed when the animal reacts to the camera. Okay. Then using Aguti, how to distinguish between encounters and number of individuals? Maybe this question, Jim or Patrick, if you are there, can you answer this question?
So for this, there's no need, because the methods assume that animals move randomly, or at least cameras are randomly positioned with respect to the movements of these animals. And there's a certain likelihood that they cross the detection range, the detection area. And it doesn't really matter what individual that is. There might be a few weird cases. For example, if the camera happens to be right next to a burrow or something, and then you get inflated capture rates. But if you do enough replication, that won't matter that much. Do you agree, Marcus? Or would you kick out these extreme capture rates?
Extreme capture, just to agree, yes. Essentially, these methods don't require any keeping track of individuals. So essentially, the criterion is if you have a new record of an animal entering the detection zone, you don't need to make any judgment about whether you've seen that individual before. That's a new encounter, regardless. In terms of these situations where you hit an incredibly intensively used area and you get a big spike in the number of records. I don't know if I have a really good solution to that. I've experimented with using some sort of outlier identification statistics, which seem to help, I think, to stabilize the estimates in those cases. They're not very common, but I don't have a really established solution to that yet.
Okay, so no more question by now. Okay, one more question in the
Sorry, go on.
Thank you. So yeah, one more question in the chat. How much time it takes to all the data per encounter? Just thinking the amount of time necessary to process few thousand photos. Yeah, it's a little bit time consuming. Even, I mean, we use the traditional or the manual estimation of distance, or even I think the calibration new one. In this paper that I saw in the last slide, we include some details about the time effort needed, but for sure is a lot. I mean, but also in my opinion, if we are able to estimate or to classify, the species automatically using this Western model approach in Aguti. In my opinion, this is usually the most time-consuming process when analyzing camera trap data. So in this case, likely or hopefully will be optimized in the coming months or weeks even. It depends how reliable is this model to your studio area.
Yeah,
And in the mean,
I was just going to say the same as Pablo was saying. I think that it's still time consuming, the clicking on the legs and this, but if we win, we can make an enormous time gain in time by using the artificial intelligence to define where are the species we are interested in. So the wild boar and having this run through your thousands of images and then selecting those which you need to do calculations of speed. I mean, we're not going to do this for all species in the whole data set. We're going to do this for the wild boar or the roe deer we're interested in. So by running the artificial intelligence first on the data set and then having your calibration and then calculating this for the specific animals, this animal location, I think we will win a lot of time. It's still time consuming to do it, but it's surely less time consuming than doing it without artificial intelligence and outside of the current Aguti system. So yeah, I think we're making progress, which nevertheless still the question if we need the density, of course, still is a valid one, which you have to consider regarding the time effort you need to calculate the densities. But if you need them, I think this is the quickest way of doing it.
So yeah, just to provide some data at this respect regarding this question, I found here the table that is included in this paper in Journal of Applied Ecology. So focusing on REM here, this is the time in minutes needed to estimate the parameters. Okay, so the time for classify the picture and to identify the species is not included here because, I mean, in our opinion, this is independent of what you are using or what you are doing with your camera trap data, because you always need to see all the picture and then you are working to wild boar or fox or rabbit, select the photos of your species. But here you have some data and for a given density, because this is also quite relevant. So for the red deer, here we include 2 study areas. So in this case, the red deer density was close to 30 individuals per square kilometer. Okay, it was around 15 more or less, if I'm right, 10 or 15 individuals per square kilometer here. And obviously the foxes is the less time-consuming species because also the density was lower, was around 1 individual per square kilometer. So less density, less photos, and then you have less time, or you need less time to estimate the distance and the detection radius and so on. Any more questions?
I have one, Pablo. Have you been basically tracking all individuals that you caught, or some sort of random subset up to you got to a certain amount that was enough for a precise estimate?
Yeah. Actually, what I usually done is when I have all the photo classified classified by species, in my experiment, I have a look more or less about the number of encounters in total in all the cameras. And potentially I didn't subset I didn't randomly select some photos, but instead what I usually did is to subset by a sampling period of the survey. So let's say that, for instance, I usually work with around 150 or 200 encounters, group encounters, okay, because I saw this on the metadata of the picture classified by species. So if in a simple example, let's say that I have 1,000 of photos of wildboar, for instance, in all my survey, then I need only the 20% of this survey period to have around, obviously, this is like a general number, but around 200 independent encounters. And then I have said, for instance, I don't know, if the survey is 2 months and I need the 20% of 2 months, so I select 2 weeks or 3 weeks. And then, I mean, probably the random selection of location, or the random selection of encounters, as you say, the result will be quite similar, but I prefer to subset to a shortened survey period, if it is possible, to avoid problems, for instance, I mean, you know, the growing of the vegetation, for instance, because if you are sampling, in my experience, if you are sampling in spring or now in the autumn, and you have a longer survey period of 2 months or 3 months, for instance, potentially the vegetation is growing, and the capability of detection of the camera traps, in my opinion, should be different depending of the density of vegetation. So then, if you work with a shorter sampling period, then you, let's say that at least the detection zone or the capability of detection of the camera is more constant during all the period, and also the animal movement, as you have seen, that obviously the day range or the activity level in a wildboar in UK is probably, and for sure, totally different than the wildboar movement in Spain, but also there are seasonal variation because of the hunting or because of the food availability and so on. So in my opinion, if you work with shorter survey periods and with enough data, obviously, always, you decrease the variability, the intrinsic variability, also in your target species, but also in your camera trap device, I guess.
But wouldn't it be more efficient to set like a target number, like I use the 25 to 50 as a so not a certain percentage, but just up to a certain number of individuals, and so then the average gets stable, and it doesn't matter. Adding more doesn't matter that much anymore.
I mean, I did exactly the same. Maybe I didn't explain properly, but
okay.
I work with a constant, a limit. In my case, it's around, as mentioned before 150 or 200 independent encounters, because then you have some encounters with only one photo, some encounters with the animal reacting to the camera, and so on. So then from these 200,000 encounters, the final number of speed estimation, or the final number of whatever radius and angle and so on, is never 200. Is lower. I don't know how much lower, but always is lower. So yeah, but at the end, I mean, I can randomly select 200, for instance, sequence in all the period, or I can select subset the period to work with 200. But the number, theoretically, the number of clicks that you have to do, or the number of clicks and estimation and so on, should be quite similar in both approaches, I guess. Any more questions? Maybe there are no more questions, Joaquin.
I think Joaquin is not in the meeting in this moment.
So what we can do, finish now, if there are no more questions.
I have a question about how people have been deploying, gathering data in the field at the deployment. So I'm aware of the two. So the calibration poles for using the photogrammetry methods, and then there's the marking out positions of known distance in the field. But has anyone been setting out these plots, triangular plots, in order to use the REST model? Is that being done commonly, or is that we're not collecting data for that at the moment?
No, probably. I mean, no one did that, Marcus.
Okay.
Or at least we recommend to say this natural reference at 2.5 meters, 5 and 7 meters and 10, and also to do the calibration fault for the photogrammetry, but the triangle for the areas, no one's at least that I know, no one did.
Yeah, just to add, Pietro in Castelporziano applied the REST model, but he started from Aguti, so I should check with him on which base that he how did he treat the data afterwards to apply the REST. So I will check with him, Marcus, and I will get back to you. I have to contact him anyhow this week. So
I think there is some. I don't have great data on this, but I think particularly if you're wanting to estimate densities for a wide range of species, there's quite a strong assumption in REST that the detectability is perfect within your plot. And I think it's hard to satisfy that assumption for all, to have a single plot size that satisfies that assumption for all species, probably.
But couldn't you not, based on the data and the entrance angle and the calculated distances, apply a kind of distance sampling scenario to calculate the EDF?
Then it becomes camera trap distance sampling. They're essentially the same thing, with either probabilistic or assumed certain detection.
Yeah, and get it back to an EDF.
Yeah.
And calculate this way the triangle of which you have a 100% guarantee.
Well, in that case, I would just use distance sampling. I wouldn't try that calculator. That's essentially what it's doing. Stoyan.
Considering what Marcus have asked, I also have some more questions about the REST approach. First of all, if we knew the distance, the exact locations of every animal, and if we predetermine the so-called focal area, we can analytically, let's say, determine if the animal is in the focal area and the staying time there. But what do you think? Should we use the analytical approach, or we can just use some transparency, let's say, software to use pictures one after another to determine visually where the animal is in the focal area? And what about because there are different approaches here. I have seen a presentation from Nakashima where they determine the focal area, and then the animal is in the focal area only if the 4 legs are inside. And we can use only our approach to determine the position according to for example, one of the foots, let's say the right leg of an animal. And my third question is about Aguti. Are we going to apply this approach also with Aguti in the time coming? If you understood my questions, or should I make it clear?
So the final question there was whether Aguti will support using the REST model. The earlier ones were, how do you determine whether the animal is inside the plot or not? Is that right?
Yes, because they used the 4 legs inside the focal area, and just this time is considered, or if we determine only that the first time when the animal enters with the foremost foot, for example, and when it's a little bit tricky to determine when the animal is outside the focal area, and it is crucial for the calculations, I think. And the main challenge here is also to determine the exact focal area, because
exactly.
yes.
So, I mean, that's the reason I asked whether anyone is deploying cameras in such a way as to define plots in front of the camera. And if nobody is doing that, then my sense is that there's, at this point, there's no sense in having a method for analyzing those data if no one is collecting them in that way. But I don't know if someone else has a clearer idea of what the plan is there.
Also, they use video captures, not frames of pictures about this method originally, I think. But it is the same. What do you think? Also, if you know the distance and the angle or the exact location, you don't need a reference triangle in the pictures. You just need to know where the animal is, and if you know the triangle you are interested in, the focal area, you can easily determine what time the animal is inside, because you know the exact position of the animal every time. So you don't need to you don't need to in the field to mark the focal area. I think you can determine it later, isn't it?
Yes, in principle, you could do that.
Okay. Now, first I provide a short answer to the question from Marcus, but okay, obviously now that we are more in detail, the problem with RES is that this assumption of perfect detection in this triangle is quite a big assumption, let's say, and obviously when we did the first course, we cannot say, okay, we are going to assume this perfect detection for all the study areas in Europe, because actually we know that the capability of the camera traps detections, there are a plethora of papers saying that this depends on your target species, the period of the day, the vegetation density, the air humidity, and many other factors. So that is impossible before to start any study to say to all of you, okay, the perfect detection for the RES will be from, I don't know, 2 meters to 5 meters, for instance. So then if you are thinking in apply REST, you need first to do like a pilot study or something like that to estimate using distance sampling that mentioned before how the detectability for your target species and in your study area and your cameras is for a given species, and then with this information you can create this triangle of perfect detection, and then after that, let's say, to start the experiment the real experiment to estimate the density. But you can, I mean, it's not reliable in my opinion, and probably you will introduce a huge bias if we say we are going to use this triangle of detection for even camera in whatever in any place of Europe in which you are working. Okay, so this is un poco this is the rationale behind of our decision. And regarding your second question, Stoyan, about the 4 legs or 1 legs to consider if the animal is inside or outside, what I should clarify here is that is more or less, in my opinion, is similar to the estimation of the speed. For instance, when working with random encounter model, if you remember the example of the road deer that Patrick saw this morning, he always use the same location, the same leg. For instance, of you can use the center of the body, but this thing that we use the same leg, the front leg, in all the picture in the sequence. So you need to be consistent, obviously within, especially within a sequence. So if you are estimating the distance, and then the speed of a road did, you need to use always the same reference point. And for the RES, I think it's more or less the same. If you are working always with the front leg, let's say, you need to estimate the staging time or consider a new encounter with this front leg is inside of the detection zone. Always. I mean, this is your criteria. If your criteria is that your reference point should be the body center, so then, or when the four legs are inside of the triangle of detection, then you need to be consistent in all your photos to use these reference points. Okay.
I have a question. I'm still struggling to understand how you integrate this triangular data within Aguti. This is a question to you, Pablo.
So how we integrate you mean in the rest
The triangular data that this field calibration data
in Aguti. You say Aguti. Okay. Yeah. So here, let's say that you have two options. Okay. So if I will ask one question before. Do you calibrate your cameras with the pole or not?
No, we did not, because in our agreement we only got this triangular calibration method. That's what we use. That is what we are using right now. And I'm just thinking maybe we're just wasting time. It's just it's kind of additional effort.
Okay, so if you didn't use the photogrammetry method to, if you didn't calibrate your camera trust photos, then you can use Aguti, for instance, to share the photos with your partners or with your students or whatever. You can use Aguti to automatically classify by species using the Western model of Europe. But for the estimation of distance and angles and so on, you can still use Aguti, but just to visualize the picture, not for anything more. You can use Aguti for that, to open the picture and see and so on, in case that you prefer to use Aguti for that, especially if you upload the photos and then you classify, you classify by species on Aguti and so on. But the estimation should be done manually within Aguti or outside Aguti, okay? And potentially you can work from the early beginning outside of Aguti. I mean, you set the cameras, you download the memory cards in your computers and so on. You open the pictures in your computer with any software to open, the normal software in Windows or Mac or whatever to visualize the picture, and then you can work totally outside of Aguti. Okay, is clear now or not? In other words, if you click, this example that Patrick did before, clicking the front leg of the road deer and so on, if you do that in your photos, but you don't have the reference photo with the ball, is nothing. You will never get the distance from the animals because you don't have the calibration pictures. Do you understand now?
No, I'm not quite understanding, because we have not been told to use this photogrammetric calibration. In our agreement, it was only triangular method. And now I'm thinking how to, once we collect the cameras, do we have to do this photogrammetric calibration?
No.
To be able to use Aguti.
Your cameras are now on the field or not?
Yeah, sure, they are out in the field.
Okay, so if your cameras are now on the field, you can go the next time that you go to the cameras. This protocol that we actually explained in the first course in April, more or less, I guess. So you can calibrate your cameras the next time that you go to check the batteries and so on. And from this calibration, using the photos before, in case that the camera is not moving, okay, you can check if the camera has moved or not a little bit. But from this point, the next time that you go to the field, do the calibration. And if you continue doing the calibration in front of the camera each time that you come back to check the batteries or the memory card and so on, then you can use the Aguti tools to estimate the speed and the distance and so on. But if you set the cameras, let's say 1 year ago, and you don't have the photo with the pole, then it's impossible to use this automatic tool.
So what I understand is the two types of calibration in this camera calibration and deployment calibration. That's what the protocol says.
Yes. Yes.
So we've done only deployment calibration.
Yes, because camera calibration, as we discussed already
And without
this morning,
camera calibration, it's no good. The deployment calibration is no good. Is that what I
mean, the camera calibration, so let's say that you are working with Browning, I don't know, whatever model of Browning, then the camera calibration should be uploaded by on Aguti by the, I don't know who, someone from the observatory, okay? So you don't have to do the calibration of your camera model because...
So it is already calibrated?
By you? Or not?
No, not by me, by you guys before sending to me.
Yeah. So yeah, this information is in Aguti right now, or should be in Aguti very soon. I'm not sure about that.
All right, now I can. So it's already the cameras. Before I got those cameras, they had been already calibrated.
Yeah, but then,
Am I correct?
but you have to calibrate your deployment.
I did, yeah. That's what we are doing. We've been doing that.
Okay, so then for sure you can use the Aguti. Sorry, I didn't understand you before. So the camera calibration is done by the members of the observatory. This information will be uploaded to Aguti.
I've never heard about it before. You guys never mentioned it before, so now I know. Now I'm following you. So
I think that Patrick mentioned before and Joaquin, but in any case, if you are using the cameras that the members of the observatory send to you, then you don't need to be worried about the calibration of the cameras.
Now it's all clear.
The point, Alexander, is that we distributed the agreement by the beginning of 2022 or late 2021, including the former protocol. But in the course we organized in June, we presented the new methodology and we distributed the new protocol. I don't know, maybe you did not attend this course or...
No, we've never gotten any invitation to that course.
Okay.
I only got an invitation to this second course, second training.
Okay, I don't know. So I don't know what happened. So I don't know if it was a discoordination by us. I don't know. But well, the point is that you calibrate now deployments in the field. You can make use of AE. Okay.
Yeah, good. So we are all set. No, there's no problem.
Yeah, and you have also the videos. The first course was recorded in video, and Jota shared the link for the videos in the chat window.
Sorry for that, Alexander.
As long as we are on, we are okay now. We are all set, so no problem.
Yeah.
Thanks.
Stoyan, you're mutated.
Yes, if there are no more questions, I have one question to Marcus. Is your package CT trapping implemented in Aguti? Because I used it independently and found it very useful. So is it the same actually what is done here now in Aguti? And we are just using Aguti to classifying images and for tagging them. And then actually this package is the engine of calculations, is it?
Yeah, so
Right.
what we're currently doing is streamlining the CT tracking functions into a new package, into Camtraptor, so that it's a single unified place for all of those that interfaces as seamlessly as possible with Aguti. So the functions, there's no plan at the moment to make those functions accessible within Aguti, but as I say, the interface between the Aguti data export and those functions should then be very seamless. So that's what we're currently working on.
So it will be the second package we will be waiting for in the end of this month, or?
Yeah.
Okay, thank you.
That's right.
There are some questions in the chat from Jordi. If we use a different model of Browning embodied by you, we have to send to Tancredi the image with the sticks calibration first. Thanks.
So yeah, I think this question, but I assume Jota that all the, I mean, if we provide the cameras, then all the cameras that we provide should be calibrated by someone of the observatory, right?
Yes, cameras are calibrated centrally. Okay.
Yeah.
So you don't need to worry about
Yes,
this.
I can explain, please. If we use different cameras that you send us, another model of Browning, I think Tancredi send us an email explaining that we have to send images for calibration of other types of or other models of cameras. So what kind of images can have we have to send to calibrate this kind of cameras, different models of sensing?
Okay, now we understand. You are speaking about a model that we do not normally use. Well, let me discussing this with Jane and Patrick, because I think they are centrally calibrating cameras. I don't know if you can add anything, Patrick.
Yeah, so I understand. I haven't done this myself, but so if you use a camera that for which there's no calibration yet, so not one of the standard cameras, but a different one, then you can collect those calibration images for the camera model yourself on a following the protocol on the parking lot or something really flat, huh? And then so carefully following that protocol, sends those photos to Tancredi or to Yorick, and then the camera calibration will be done for you. And once it is done and you select that camera as the camera of your project, it will automatically be you will automatically get the right numbers added to your, and then the only thing you then need to do next is do the deployment calibration. And anyone after you using that same camera can benefit from your camera calibration. Only one person needs to do this once. So if you use a different camera and nobody did it before you, then you're bad luck for you. You have to do it.
No, but
Patrick,
how we can know the models of cameras being calibrated in Aguti? There's a list.
That I do not know.
I believe so.
Because perhaps my model is yet calibrated.
Yes, it's possible. And I cannot tell. So I think best to ask is just ask, send an email to Tancredi or to the Aguti project asking, is my model already calibrated? and then you know whether to do it or not. And you could do it in the office right behind you. Huh? It's you can do it inside. You don't even need to get wet or hot. Inside
Yes,
is okay.
Okay.
Just need some space.
We are summarizing the main remarks after this course, and we are going to distribute a circular. And obviously, we are going to mention this point, Jordi.
Okay, thank you.
Patrick, one point to clarify, the calibration is specific for camera trap model or is specific for camera trap model and pixel resolution? Because if
oh yeah, that I think that combination, because if it's a wide angle, for example, if your camera has two settings, a wide angle setting and a normal 4:3 setting, that has a completely different distribution of pixels and also different use of it's basically two different angles. So yes, that is different. And to be honest, I don't know how that would work.
so then we need the calibration, for instance, regarding with the question from Jordi, if let's say that he's using Reconyx Hyper 5, whatever.
Yeah.
It's not enough to know that the Reconyx Hyper 5, whatever, is calibrated. We need to know that the Reconyx Hyper 5 is calibrated for 4 megapixel, 12 megapixel, and so on, or not. Because I mean, if the camera is calibrating for 4 pixel, but he's using 12 pixel quality in his experiment.
I don't know that. I do know that if so, yeah, some cameras offer wide angle versus normal, then it matters. I don't know whether the resolution matters for the angle. I suppose not, but I'm not sure. Do you know, perhaps, Marcus?
Resolution also matters, so it needs to be the combination of camera model and image setting, which includes resolution and format, is the unique. You need a separate camera calibration model for each combination of those things.
Okay. So I mean, this is something that everyone should take in mind when setting the pixel quality, and then when crossing the data in Aguti, that you should select your camera trap model, but also the pixel quality that you set in your cameras.
It also helps to make sure that you use a consistent setting, if possible.
Yeah, theoretically, we will have used all of us the same setting.
Yeah.
But double checking.
Okay, we normally recommend in the protocol, if I'm not wrong, Pablo, to use the low quality size in order the picture not to be too heavy. But however, I think it would be also recommendable to include this information in the field sheet where we indicate different parameters to indicate the data model and also the resolution at which the camera is used for this specific deployment. Okay.
Can I say something else? So this is about the time offset. So you all have been placing cameras in summertime, right? Central European summertime. So if you set the UTC offset, it's not 1 hour, it's 2 hours. So the normal Brussels time that you choose in Aguti would be the winter time. That's the normal time. And you need to choose +2, that's summertime. I think maybe that could be in the menu, that could be clearer, but realize that your offset is +2. If you use this link, timeanddate.com, you notice what the real offset is, but it's intuitively you might choose Brussels and then you're wrong. Just one thing to keep in mind. So UTC +2 hours is the choice for deployments that started in the summer. Is that clear?
Okay.
There is one question in the chat about the Aguti and calibration. So, Patrick, I don't know if you prefer to answer this question.
Oh, sorry.
last one from Valerie, I think.
How can we import the
Hello.
calibration to the field experiment? Oh, you mean the calibration of the camera? So once your camera has these data are in Aguti, then simply selecting the camera for the project will do the job. You will then have these values. That's what I understood. But let's check how this works. And if you want to make sure, always just email Aguti to ask, hey, is my model in there? And will the numbers automatically be added to my project?
Okay, yes, because we have just checked if we could select the type of camera in Aguti, but we couldn't. So I was wondering how we could select a calibration then.
Yeah, that will then obviously it's not in there yet, but you can still do the deployment calibration. It's these numbers will be combined afterwards if I'm correct. I didn't build this, so I'm not 100% sure.
Thank you.
So are you using the standard model of the EOW?
No, not the standard model. We didn't receive that model. We used another model.
Okay.
Can you remember the name?
So then what you need to do is get in touch with Aguti at word.nl with Jork and say, hey, I want to do a calibration of this model and get it added. And he will then ask you for calibration photos, probably. Or Tancredi may do this. I'm not sure.
Yes, in the email that Jordi mentioned before, there's attached instructions, but I can send them again, of course. But there's
please do. Yeah.
There's yes, quite clear instructions of how to do that, and I'll send them again so that everyone has them.
Okay, and then Tancredi, and we need to make sure that these things are then done per if the model has different settings, that we do have different specifications per different settings, because that obviously matters.
Yeah,
so
that's also specified in those instructions that the calibration has to be specific, not just for the model, but also for the settings that have been used for the
okay,
for the
all
deployment.
clear.